Hello, and welcome to Virtual Investor Conferences. My name is Matt Lateplo, and on behalf of OTC Markets, we're very pleased you have joined us for our next live presentation from Applied Energetics, Inc. Please note you can submit questions for the presenter in the box to the left of the slides. You can also view a company's availability for one-on-one meetings through the Schedule Meetings tab found on the conference platform. At this point, I'm very pleased to welcome Chris Donaghy, CFO and COO of Applied Energetics, Inc., which trades on the OTCQB venture market under the symbol AERG. Welcome, Chris.
Matt, and thanks for joining me, everyone. As Matt mentioned, my name is Chris Donaghy. I'm the Chief Financial Officer and Chief Operating Officer of Applied Energetics. We are based in Tucson, Arizona, and we are a leader in ultra-short pulse laser directed energy solutions. And I want to point out that this presentation that I will be walking through is available on our website, appliedenergetics.com. Next slide is our safe harbor statement, as we will be making some forward statements throughout this presentation. And I'd like to begin the presentation with our vision statement. Our vision statement is directed energy anywhere, and this is an ambitious vision statement, and hopefully over the next few minutes you'll understand us, what we're trying to do, and get a better feel of the importance of what this vision statement actually means. I want to quickly talk about what you're seeing here, but the first thing I would like to do is define directed energy. So a directed energy system is a system that damages a threat with highly focused energy. The most common of that being light energy, or a laser, or microwaves, commonly referred to as high power microwave. To accomplish this vision, three things are going to need to converge. First, you're going to need to see a widely proliferating threat. As you can see here, we have a representation of a drone system that is vulnerable to the effects of directed energy. Then you have to be able to develop a system that can deliver those high value effects at a tactical range that is relevant to a national security problem. But maybe more importantly, you need to deliver those effects using an optimal size, weight, and power platform that will allow you to deploy these types of systems to any location, whether it's a mobile platform, such as a ground vehicle or a naval ship, deployed to deployed locations where we have troops deployed overseas, or in fixed sites. This is, again, as I mentioned, this is an ambitious vision statement, and hopefully over the next few minutes, it will come to make more sense to you. This is our mission statement: innovating and shaping the future of directed energy technologies that defend our warfighters and critical infrastructure. And we do that by matching the ultra-short pulse laser capabilities that we are developing to specific customer mission problems, where the effects that an ultra-short pulse laser can provide their maximum value against a particular threat type. The structure of this presentation is basically four parts. First, we'll talk a little bit about what the problem is that we're trying to address. Second, we'll talk about the solution that we are developing to address that problem. Third, we will talk about why we believe we are uniquely suited to develop and deliver those capabilities. And then fourth, we'll talk a little bit about what the market looks like, what we think the market looks like for these kinds of capabilities. So first, let's talk about the problem statement. So I'm sure many of you follow the news, and you know that what's going on in Ukraine, what has been happening in Israel and other parts of the world, we are seeing a dramatic rise in the use of drone systems. And those drone systems are going to be in the air, they're going to be on the ground, they're going to be on the surface of the water, they're going to be under the water. But the use of these kinds of systems is dramatically increasing in number and capability. And as those unmanned systems increasingly augment humans on the battlefield, you're going to find that sensors, the things that these drones use to find their way around, those sensors are going to saturate the battlefield as well. The vast majority of the sensors that are on board these platforms are cameras. Most of the systems that are being used today are being flown by a pilot who is staring at a screen with a video feed coming off of a camera. And those camera systems are highly vulnerable to the effects of ultra-short pulse lasers in particular. So our solution that we're bringing to market, as you will hear shortly, it goes after the camera system and it attempts to destroy those systems at tactical ranges. We can't talk specifically about what those ranges are, but it's destroy those sensors at a range that is far enough away to effectively neutralize the threat from being able to accomplish its mission or strike its target. So we've been talking about lasers for a really long time, and this sort of reinforces some of what we talked about on the vision statement. What you see here is a typical technology adoption curve. And what you see here is that directed energy technology in general, lasers, high power microwave, or otherwise, you have not yet seen the inflection point where these systems become widely adopted. And the reason why is because while high energy lasers can deliver really cool effects against targets that are susceptible to those lasers that have been deployed so far in various military programs do not have a size, weight, and power profile that would allow you to deploy those types of systems wherever you would like to put them. So we think we are positioned to be a catalyst to see the bend in this curve, because we believe we are driving the convergence of those three things that I described in the vision statement. We do have a widely proliferating threat that is uniquely suited to being countered by directed energy weapons. We are developing capabilities that deliver high value effects that can significantly damage those threats. But more importantly, we are taking a size, weight, and power approach, an architectural approach that will allow the systems that we're developing to be deployed on virtually any platform you want, from the largest Navy ships down to the smallest ground vehicles that you might see used in small unit engagements in the Army, Marines, or other ground forces. So again, the main point of this slide is we think we are well positioned to be a catalyst to cause the bend in this directed energy curve, in the adoption of directed energy weapons into the national security space. So the solution that we're bringing to the fight to solve this problem is a particular class of laser called an ultra-short pulse laser. A couple of things about that laser. First, about the lasers we're developing. First of all, we're using a common underlying architecture across our family of products. This is going to increase the reusability of the various components that we're developing, which will allow us to more effectively build and assemble these types of products. Second of all, we're doing this across multiple wavelengths. So we are actually building a family of lasers that can be matched to particular sensors and the vulnerabilities that those sensors may have. And again, the most important thing is we are doing this in an efficient, compact, and ruggedized architecture that would allow you to put these capabilities whenever you want, wherever you want. Point number two is important as well. So an ultra-short pulse laser delivers a very high peak power, which you'll see in a couple of slides, that allows us to do significant damage to the camera systems on these drones, again, at tactical ranges that would allow for a sub-second kill of that sensor. One of the drawbacks of the current laser technologies that are being deployed in national security situations right now is those types of lasers are called continuous wave lasers. And a continuous wave laser requires locking onto the target and essentially burning through a structural component that would cause the drone to crash or fail. The main point there, though, is that it takes time for that effect to occur. And with an ultra-short pulse laser, because we are targeting the parts of the drone system that are highly vulnerable to those ultra-short pulse lasers, we believe we will be able to deliver a sub-second kill. So you can target one system, quickly move to the next one, and achieve the same type of effect. And that is very unique relative to the types of laser systems that you are normally used to thinking about. Here's what this looks like kind of in reality. This is an ultra-short pulse laser test that we performed in our lab late last year. This is against a very common commercial sensor that you would find on drones that you could buy at Best Buy. ranging from lower end drones all the way to higher end drones. But essentially what happens is at a long enough range or a low enough laser power level, the first thing that happens is you start to blind the camera system. That's what you see on the far left-hand side. So we saturate the sensor with energy, and the sensor can no longer image what is around it at that time, and it's essentially blinded. But if we turn the laser off at that point, it would be able to reestablish an image. As the target gets closer, or as you increase the energy level, you start to do damage to the focal plane array, or the sensing unit of the camera system. So what you see in this middle image is we've taken out several pixels, and we've started to take out different elements of the camera system, doing more permanent damage. But if you deliver enough energy, what you get is the right-hand side, where we have in essence taken out enough of the surface material of the camera such that it will fail to operate. So again, in a deployed situation, we're doing this at a tactical range. So the operator who is staring at the screen, who may have a long way to go before they get to their target, or in the case of an ISR, an intelligence, surveillance, or reconnaissance drone, where he's popping up over a hill to see if there's a threat there, again, in less than a second, we can target that camera and essentially take out the front surface of that camera so that it no longer is able to operate. We do that in less than a second, and now the drone is blind and highly unlikely to be able to accomplish its mission going forward. So this is the high value effects that we can deliver against that problem, which is the proliferation of drones with sensors on them. Again, the more important part of this, however, is we are taking an approach to be able to deliver this capability using a size, weight, and power footprint that is substantially lower than what you see out of the continuous wave laser systems that you see on the news today. And you can see here the footprint of the system. It's roughly the size of 2 shoe boxes, very small. More importantly, when you compare it to even the lower power continuous wave systems, you can see we are dramatically smaller in footprint relative to, again, a relatively small continuous wave laser systems. And the things I'd like to point out here is look at the differences between the peak power of the laser. This laser on the right-hand side is designed to generate about 10,000 watts or 10 kilowatts of laser energy out of a box that is roughly 5 feet by 3 feet by 4 feet and weighs thousands of pounds. And when you plug that into the wall, it is a massive amount of power that it needs to draw in order to produce that 10,000 watts of energy. On the left-hand side, you see an ultra short pulse laser. 10 to the 10 watts, that's tens of billions of watts of peak power, while consuming about the same amount of power as your garage door opener. So 1 kilowatt of power is not a very big power draw at all. And we're talking tens of pounds of weight versus thousands of pounds of weight. So this system on the left, because of the size, because it has relatively low power draw, you'll be able to put this system wherever you want. And that is really the advantage that we think ultra short pulse lasers have the potential to bring to the fight. A very significant and dramatic improvement over the current continuous wave systems that are being deployed to try to solve this problem. So why applied energetics then? Well, our chief scientist has been doing pulse lasers for over 20 years, probably 25, 26, 27 years. And he has developed a significant IP portfolio around ultra short pulse lasers used in directed energy applications. 25 awarded patents, 11 patent applications that are held under government secrecy orders. So those patents, you could not find those patents on the U.S. Patent and Trademark Office website because the government wants those protected. They don't want those patents made public. And then we have continued to develop new IP with 10 additional patents pending. We've also built significantly large ultra short pulse laser systems. We built one for the Navy back in the mid 2000s. That was a terawatt class laser. Terawatt is 5 trillion watts of peak power, and we did that in a relatively short period of time. And the long and short of this is our experience and the IP that we have in place has enabled us since mid-2022 to be awarded 3 different contracts by 3 different organizations for 3 different effects. And to my knowledge, we're the only company in the defense industrial base that has not 1, but 3 contracts in hand to develop these kinds of capabilities for specific and important customer mission problems. As I mentioned, highly experienced team. Dr. Greg Quarles recently served as the chief scientist of the Optical Society of America, now known as Optica, and Dr. Steve McCann, our chief science officer. Again, he is probably the most well-known scientist in the field of developing ultra-short pulse lasers specifically applied to directed energy or national security types of applications. As I mentioned, we're doing this in Tucson, Arizona, based in the University of Arizona Tech Park. We recently signed a new lease on 5,000 additional square feet of floor space, where we will be doing 2 things. Number 1, we are in the process of transitioning the lasers that we have been tasked with designing under those 3 contracts into transportable demonstration systems. And so the new space is going to have, in essence, a battle lab or a range where we can take those lasers and fly real drones at the other end of the range and begin the process of taking this system from the tabletop into a demonstrator, into a prototype, and ultimately in production, which is what the rest of the new facility will be used for, which is building out the manufacturing capability to transition these lasers now from science into reality and hardware. This slide is what I like to call the why now slide. So there has been a lot going on in the company since 2018. We started developing the architectural approach that we've in early 2018, and we have now seen the award of contracts to take advantage of that architecture to deliver effects. Again, 3 different customers, 3 different applications. The first application is likely going to be counter ISR. It's targeting the sensors on board drones, but it actually could go beyond targeting just drones to targeting other systems. I will say, as we've been going through this, we have found that there are certain technologies and components that we have found to be difficult to source. So we have also embarked on a vertical integration strategies to start building some of our own enabling technologies and components, so that we have, number 1, a reliable source of those components. Number 2, we have a domestic source of some of those components. As you can imagine, a lot of the types of components that we're needing are generally derived from the commercial telecom market, which means a lot of those products are produced in places that we don't want to incorporate into our production system. So again, vertical integration to be able to do a lot of this on our own. But there is more coming. We have right now probably the most active pipeline of new proposals that we've ever had in the company's history for additional national security applications. But as we're developing these capabilities to solve national security problems, we're also going to see opportunities to transition those technologies from a national security problem toward a commercial domain that has significant attractive market characteristics as well, mainly in the biomedical research and scientific markets and the advanced manufacturing market. So let's talk a little bit about these markets. And I'm going to focus primarily because it's where the vast majority of our work is being done right now, but it's in the directed energy weapon systems and in counter UAS. So again, if you look at what is happening in Ukraine today, what is happening in the Middle East with drones, counter UAS or counter unmanned aerial systems is going to be a substantial market for us. And if you just think about the number of different places where we deploy troops, we have troops deployed to hundreds of different locations around the world. It's somewhere around 400 different locations. As drones continue to proliferate, the DoD will start to deploy a layered defense approach, which is going to involve multiple kinds of technologies to defend against those particular drones. They're going to include radars and other systems to do detection and tracking of the drones. They will deploy jammers to try to interfere with the electronics on the drone to cause the drone to lose its signal to its operator. And we believe they will deploy lasers to ultimately damage the drones enough to substantially degrade their mission capability. And it's likely going to take multiple of these systems per site. So if you look at, for example, 400 deployed locations, you might need 3 towers per location. So just defending against deployed sites, we're looking at a potential market of 1,200 units for that one application. And there are going to be multiple other situations, whether it's defending larger platforms against other types of threats, deploying it on smaller ground vehicles for small unit protection as they're executing their job. Again, the market opportunity here we think is quite substantial. The other numbers that you see on here, again, whether it's commercial applications or DoD applications, we expect that there's going to be substantial growth in all of these markets. The caveat here, again, is it's going to be very difficult for those top 3 applications to see the type of growth that is being projected without a size, weight, and power shift that makes these systems far more deployable. And again, that is the primary applications space that we're going after. So hopefully, I've been able to kind of answer the initial questions that I laid out for you. What's the problem? What's the solution? Why are we the guys to deliver the solution? I will wrap up my prepared remarks at this time, and I will shift over to Q&A. So if you'll give me just a few seconds to get the Q&A set up. Hold on just a second. So one of the questions that that is asked is, why can't the adversary just put a mirror and shield itself from the laser? So again, the concept of ultra short pulse lasers is a relatively exotic field, but the main point here is that, again, we are developing a family of lasers that operate in a variety of wavelengths. And the main thing is if you can build a laser that operates at a wavelength that is matched to the wavelength of the camera system, the laser is just, it has to pass through or the sensor doesn't work. So it's, because we're matched to the wavelength of the sensor system, there's really no way to defend yourself against that system. Another question is, does this system currently exist or is it still in the development stage? So ultra short pulse lasers are a relatively mature type of technology. You can find commercial vendors who build ultra short pulse laser systems that have similar performance characteristics to what we're trying to build ourselves. The problem is they have not taken an architectural approach that would be able to survive ruggedization testing by the DoD, a process we call shake and bake. So the system has to be able to withstand vibration testing because it's going to be deployed on vehicles that operate on bouncy roads, and it has to be able to survive environmental testing because these lasers could be deployed in desert environments or they could be deployed in very cold environments. So while ultra short pulse lasers as a technology do exist, what we are doing is taking an architectural approach that is specifically designed to optimize size, weight, and power and be able to withstand the shake and bake process of DoD testing. That is what we are in the process of transitioning right now. So for the last couple of years, we have been developing a tabletop system that we are now in the process of moving from the tabletop into a transportable demonstration system. And we will shortly begin the design process, the thermomechanical and footprint and all the things you need to move toward a production system. Another question is your go-to-market strategy to sell to defense contractors, or do you expect to sell and fulfill directly to the government? It's going to end up being both, but Right now, what we are doing is we are developing the laser source. We do not provide the acquisition and tracking system, the targeting system that would need to be used to actually see the drone and then point the laser where it needs to point to deliver the effect. But that is, frankly, the commodity side of the system. The big defense contractors that many of you are probably familiar with, whether it's the Raytheons of the world, the Lockheeds of the world, they have these types of systems already. We will simply integrate our laser source into those systems and then use their software infrastructure and hardware infrastructure to deliver those effects downrange. So some of that will go then through prime contractor types of contract vehicles. However, we also can use this same laser to also build our own tracking, detection, and pointing capability as well. So the long-term vision here is this will be a complete system that does the acquisition, the tracking, the situational awareness that is needed to determine what types of threats are out there, again, using ultra-short pulse lasers. And then when it detects that threat, we match the appropriate laser to that particular threat and deliver those effects downrange. So it'll end up being both in the longer term, but in the near term, we will likely be working through primes, other primes when we go into production. And with that, I think I will conclude my remarks. I'd like to thank you all for your time this morning. We certainly appreciate it. Again, the presentation is available on the website. You can see our investor relations contact on this page here. Please feel free to reach out if you have any questions. Again, thank you for your time.